Part 16, Production and Use of Complex Tactile Drawings, Example 1.
Okay, one of the examples that is difficult for a visually impaired blind student to do is one that covers a lot of different angles and lines. Because as a sighted person, we can see the whole picture at one time, where we can find angle 1 and then quickly find angle 11. Whereas a blind student who is using the Braille, they have to systematically search throughout the whole page to find the information. And John's going to demonstrate how this is difficult.
The problem consists of 7 intersecting
John, if you want
lines,
to try
and there
to
are 13
find
angles identified.
number 21, question 21.
John flips to the second page
Here we go.
of
This
the
is
test.
21. And it says, find the measure of angle 6. So I'm going to flip
John
through these
flips to the
graphs
back
here.
of the test, which contains a set of tactile graphics which have already been created.
Okay. Here's the correct graph. It wants me to find the measure of angle 6.
The lines and angles were created using the Braille writer and a glue gun, and the angles are identified in Braille.
It's angle 8.
John continues to search for angle 6.
Angle 6 is right here. But see where, okay, angle 6 is right, it's this angle right here.
The camera shows a close-up of angle
now,
6 and 2 neighboring angles.
Some of the, let's see, this one was actually kind of an easy one to do, actually. I hate to say it. Because it's not, I mean, I can tell clearly that this is the angle. Some of them, they were so close together, I couldn't tell what the Braille is pointing to. Or, you know, what the labels are pointing to because the angles are so close together. But angle 6 is right here.
Okay, look up question 18.
18.
John goes back to page 2 of the test.
18. This one's angle 3.
Once again, John flips back to the back of the test and the tactile graph.
One thing that is a little weird about this one is that some of the angles aren't labeled. These 2 angles up here I'm talking about that are not labeled at all.
John points to the 2 angles that are not labeled.
Go down. Oh, it's just a light. All right. 5. Okay, here's angle 3, right here. It's on the inside of the figure. It's this one right here.
John points to angle 3.
Good. What is one of the difficulties with now if they're asking you to find the measurement of angle 3. Now you've already found the measurement of angle 1 and 4, but how would you document that so then you wouldn't have to refigure out the information?
Well, see, problem here is that I have to, see now, finding the angle is only half the battle. Actually, 1/4 of the battle. Because now you've got to go back and look in your Braille light to see what the measures of the other angles are and how they relate. Then you have to put your hands back on the paper and find out how they relate to angle 3 so that you can find its measure. So first I would have to look up in my Braille light, which could take several seconds, and see what angles 1 and 4 look like. And they wouldn't necessarily be, you know, right next to each other as far as answers go. So I'd need to skim through a couple answers to see what they would equal. And then I'd need to try and find angles 1 and 4 on the page.
John
which are
searches
where?
for the correct
Still
angles
looking.
on the tactile graph.
Angle 4 is right here. Angle 1 is right here. Okay, so angle 1 and 4 are right here. And angle 3 is here. So, angle 3 is right here. So 1 and 4 are on the outside. 1 is on the outside, and then 4 and 3. 3 is right here. Sometimes I'm not quite that lucky, though. Sometimes the angles are farther apart. They want you to find the measure of, let's say, 1 and angle 6, and they ask you how that relates to, say, just for example, angle 13 or something like that, or angle 10. Well, that would be kind of hard to put all my fingers on those same points at once so I could see how they relate. Sometimes to get around this problem, I can use a wiki stick, and but sometimes that is pretty hard too because the angles are so, how do you say it? They're so wide that the wiki stick doesn't fit on all 3 points, and then I'm presented with a problem there as well.
Okay, we're going to, and when a sighted person is doing a problem like this, they can actually write down the angles, measurements on the print copy so that they don't have to keep going back and looking up what the angles are, whereas John has to look them up in his Braille light to find out what the angles are. A sighted person would just write it directly on the test once they figure it out so that they don't have to keep going back and forth looking up the information.
Right. Now, in other geometric problems, they give you values of certain angles. And, for example, this one just wants, sometimes I don't need necessarily to find the measures of the other angles that relate to angle 3, for example. Sometimes they may tell you, okay, angle 1 is like 45 degrees, and angle 4 is 72 degrees. And if I don't have that written down in my Braille light, then I would have to look back on the test
John
to
flips
see
back to the beginning
what
of the
the
test.
measurements were. So that
John has
entails
to
going
flip through
back to
several
this
pages before he
first
finds the
page,
correct
actually
one.
second page here. And if this question had the measurements labeled out, I would have to then search for the angles in question. And normally that's part of a big list of measurements that they give you.
And once again, a sighted person can write that information directly on the diagram so that they don't have to keep looking back and forth or remembering what the angles are.